The screen is visible to you?
Black screen, sir.
हेलो सर।
हाँ हेलो। हाँ बोलो।
सर आपने लास्ट क्लास का लिंक अभी अभी भेजा है क्या मेल में?
हाँ
सर पर मैं तो मेल चेक कर रहा हूँ, मतलब कि कोई मेल नहीं आया अभी तक।
पता नहीं कुछ
प्रमोशन
बोल
में
कल जैसा था आज वैसे ही बोल रहे हो, मुझे वो पता नहीं। कल तुम लोगों ने बोला कि हाँ आया है, आज बोल रहे हो नहीं नहीं आया है, तो मैं क्या करूँ? एक काम करता हूँ, कल का लिंक मैं चैट बॉक्स में दे दे रहा हूँ, उसे कॉपी करके रख लेना, अभी मत फिलअप करना। ठीक है? क्या बोल रहा हूँ समझ पा रहे हो?
यस सर।
चैट बॉक्स में दे दे रहा हूँ, सबसे अच्छा होगा। तुम लोग ऐसे बोलोगे तो मुझे कैसे, कि मैं क्या बोलूँ तुम लोगों को? कभी बोल रहे हो आए, कभी बोल रहे हो नहीं आए, तो कहाँ से लाके दूं? ऐसे वैसा कुछ तुम बोल, कुछ लोग बोल रहे हो हाँ लिंक आया है, कुछ लोग बोल रहे हो लिंक नहीं आया है।
नो सर,
लिंक
प्रमोशन पे चला जा रहा है वो जो आप लिंक भेजे हैं।
तो वो भी चेक करो ना, हर दिन कल भी भेजा था।
प्रमोशन या स्पैम पे चला जा रहा है आपका जो मेल, इसीलिए नहीं दिखा रहा है सबको।
मैं क्या करूँ? तुम लोग वो चेक करना चाहिए तुम्हें। फिर चैट बॉक्स में भी दे दिया।
जी सर।
नहीं मिल रहा है तो यहाँ से ले सकते हो। Okay, the screen is visible to you, I think.
यस सर, नाउ चाहिए।
Then starting the discussion with NFA with epsilon MOOCs, we can go for the things that what I have told you yesterday. I'm starting from the same position, that whenever we are going for epsilon MOOC cases, basically we have to transit from one state to other with a value known as epsilon. That is, here there is no input alphabet, without providing any symbol, and only through the help of epsilon we can jump from one state to other. And that type of move in a finite automaton is known as a epsilon move. Repeating again, whenever we are changing a state or transiting from one state to other without any input symbol, with the help of epsilon, that type of moves in a finite automaton is known as epsilon moves. And here I have shown you a transition from Q0 to Q1 with a value of epsilon. With a value of epsilon. Clear? Next, moving for this, I have gone for this example before. I am still saying you now about this. You can see here And I'm asking you, any one of you who can say what is the language of this finite automaton? Any one of you who can say? What is the language of this finite automaton? A little bit fast. थोड़ा जल्दी बोलो.
0 plus 1 bracket में start, then 1 only, then
No,
0 or
मुझे रेगुलर एक्सप्रेशन नहीं चाहिए, मुझे लैंग्वेज चाहिए. निकिता,
Yes, sir.
ये जो ऑटोमेटन दिखाई दे रहा है तुम्हें,
Yes, sir.
तो वो ऑटोमेटन क्या एक्सेप्ट करेगा, किस टाइप का स्ट्रिंग एक्सेप्ट करेगा, लैंग्वेज क्या है?
Sir, containing 101 as a substring
हाँ, वेरी गुड. और कुछ करेगा?
or 11 as a substring.
Yeah, very good. It will accept, you can see here, any number of 01 from the beginning, any number of 01 at the end. In between that, what is there? In between that, what is there? 1, 0, 1. That means here 101 is the substring. If you are moving from Q1 to Q2 with a 0, then it is 101. But if I am not going with the 0, I am moving for epsilon. That is Q0 to Q1 with a 1, Q1 to Q2 with a epsilon, Q2 to Q3 with a 1. That is 1 epsilon 1. 1 epsilon 1 is 1 1. Because whenever I will go for concatenation of epsilon to anything else, then it is the same string. 1 concatenate epsilon, it is 1. Then going for this concept, I can say this is 1 1. That means here I can say 1 1 as substring. Clear? Hence, this automaton accepts the set of strings which are containing 101 as substring or 1 1 as substring. That is 1 1 or 101 as substring. Clear? Clear?
yes sir.
Then going for its formal descriptions, I can say the formal description of NFA epsilon is it's a 5 tuple Q sigma del Q0 F, where Q sigma Q0 and F are as usual before. Only there is a change in the del, and here in del, what is the change? Instead of sigma, we can go for sigma union epsilon. Or also I can write it as sigma epsilon. That here the alphabet set is not containing only the symbols, it also contains the epsilon as well. That means with epsilon also we can make the change of state. Clear? समझ पाए क्या बोला? हेलो?
yes sir. yes sir. yes sir.
अरे तुम लोग सब हो, वो ज्योतिष क्यों हर वक्त रिप्लाई करे? तुम लोगों से भी रिप्लाई एक्सपेक्ट कर रहा हूँ. ठीक है? तुम लोग भी थोड़ा थोड़ा रिप्लाई करो. पूरा चुपचाप बैठोगे तो मुझे कैसे पता चलेगा कौन है कौन नहीं है? ठीक है?
Okay,
Then
sir.
this is the case where only the transition function differs, and in transition function here along with the inputs, with the help of epsilon, we can also change the state. Then moving forward of the concept, we are going for some of the operations based upon that. Before that, we can say whenever we are going to design any NFA, using the epsilon transition. And we are going to design any DFA. Out of that, we have to go for a concept of epsilon closure. We have to go for a epsilon closure. But before going for that, I am going for some of the other concepts. After that, I think I will go for that. Is it visible? We can see here. Yes, we can. I should go for something different, then I will come here. Come back here. Give a heading. Regular operations on NFA. Give a heading. Regular operations on NFA. Actually, in your book, if you go for, this is at the end. But for your convenience, I am going for this at the beginning. Regular operations on NFA. Okay, listen one thing. The regular operations under which the deterministic finite automaton is closed under the same regular operation, the non-deterministic finite automaton is also closed. What I told understood, repeating again. Previously, we have gone for some concept like regular operation, where we have discussed that the deterministic finite automatons are closed under some regular operation. Here, what I am saying, under the same regular operation, the non-deterministic finite automaton is closed. The reason is, as for every NFA, you can design a DFA. If DFA is closed under some regular operation, then also the NFA is closed under those regular operations. क्या बोला समझ पाए? पार्थ सारथी,
Yes, sir.
पार्थ
यस सर
क्या बोला? स्पीकर बंद करने के लिए नहीं बोला, जो बोला वो पूछा. मैं ऑन करने के लिए बोला स्पीकर.
यस सर
बोलो बोलो क्या लाइन अभी बोला. मैं देखना चाहता हूँ तुम लोग प्रेजेंट हो और सिर्फ लॉग इन हो, वही देखने के लिए ही पूछ रहा हूँ.
सर अच्छा सुना नहीं था
वही तो प्रॉब्लम है, मुझे मालूम है, इसीलिए मैं पूछ रहा हूँ इंडिविजुअली. क्यों नहीं सुन रहे? मैं अगर इतना चिल्ला रहा हूँ कुछ तो तुम सुन लो. Previously we have gone for DFA and regular operation. तो पार्थ स्पीकर बंद मत करो, तुम्हें पूछ रहा हूँ. The DFA is closed under which regular operation? ये आगे पिछले क्लास और उससे पिछले पिछले में पढ़ाया था. एक DFA कौन से रेगुलर ऑपरेशंस में क्लोज्ड होता है? What are the regular operations under which the DFA is closed? बताओ. ये बता पाओगे?
यस सर
रूपम मेहर,
यस सर
बता पाओगे कौन से रेगुलर ऑपरेशंस के अंडर the deterministic finite automaton is closed. थोड़ा सा तो पढ़ लो, ऐसे ऐसे चलेगा। राहुल सेनापति, तुम बता पाओगे?
No, sir.
मैं बोलूं तुम लोगों को, मैं सोच भी नहीं पा रहा हूँ। कितना पढ़ा गया है तुम लोग बोलोगे मुझे, हम लोगों को कुछ पता नहीं। अलीशा, अलीशा, इसका नेटवर्क प्रॉब्लम बार बार आ रही है जा रही है। शिखर, शिखर स्वरूप,
Yes, sir.
so deterministic finite automata is closed under which regular operation?
यूनियन सर, डॉट प्रोडक्ट, एस्ट्रिक, यही सब जो बनाए हुआ है।
उसका नाम बोलो, एस्ट्रिक्स मत बोलो, मैं सिंबल नहीं पूछ रहा हूँ। यूनियन, उसके बाद
डॉट ऑपरेटर,
उससे वैसा कुछ नहीं है। उसे क्या बोलते हैं?
डॉट प्रोडक्ट।
नहीं, कॉन्कैटिनेशन।
ओके ओके, सॉरी सर, कॉन्कैटिनेशन।
उसके बाद
सर ये जो
क्लोजर, क्लीन क्लोजर या फिर स्टार ऑपरेशन।
ओके ओके सर, स्टार ऑपरेशन।
और वैसा ही बहुत कुछ और है। और क्या?
और सर नहीं याद आ रहा सर।
कॉम्प्लीमेंट, रिवर्सल, होमोमॉर्फिज्म, इनवर्स होमोमॉर्फिज्म एंड सो ऑन। थोड़ा
यस
सा कर दो, ये बेटर होगा।
ओके सर।
Then under these operations, the deterministic finite automaton is closed, and similarly, the non-deterministic finite automaton is closed. And I am going for the closure property of non-deterministic finite automaton. तुम एक लाइन लिख सकते हो that the non-deterministic finite automaton is closed under union. The non-deterministic finite automaton is closed under union, concatenation, clean star, clean का spelling होगा KLEEN, clean star, complement, reversal, homomorphism, inverse homomorphism. State difference, intersection, etc. जो बोला लिख रहे हो, सीट में बेकार में बोल रहा हूँ।
लिख रहे हैं सर।
क्या जो कि speaker on है?
स्टेट डिफरेंस का
क्या हुआ?
क्या बोला?
सेट, SCT, जो सेट में A माइनस B होता है ना, डिफरेंस, वही वाला सेट डिफरेंस, इंटरसेक्शन। फिर से बोल दे रहा हूँ, चेक कर लो। यूनियन, इंटरसेक्शन, concatenation, clean star, set difference, complement, reversal, homomorphism, and inverse homomorphism. Under these operations, the non-deterministic finite automaton is closed. Then here I am going for some of the examples of that, how these non-deterministic automatons are closed. Let A1 and A2 are two languages recognized by two NFS, N1 and N2. A1 and A2 are two languages recognized by two NFS, N1 and N2. Then how to go for their union, intersection, and state difference? How to represent the union, intersection, and state difference? Then if I have two automatons, समझ पाए क्या बोला, मीनिंग समझे? I have two automatons known as वह एक है N1, दूसरा है N2. तो एक ऑटोमेटन में एक ऑटोमेटन में क्या होता है? एक इनिशियल स्टेट होता है और एक फाइनल स्टेट होता है कि नहीं? हर ऑटोमेटन में एक इनिशियल स्टेट होता है और एक फाइनल स्टेट होता है.
यस सर.
तो मैं उस हिसाब से बोल रहा हूँ. मेरे पास दो ऑटोमेटन है, एक है N1, एक है N2. N1 लैंग्वेज A1 को एक्सेप्ट करता है और N2 लैंग्वेज N2 को एक्सेप्ट करता है. And for that I have designed two automatons like this. ये दो ऑटोमेटन, एक ऑटोमेटन है N1, दूसरा ऑटोमेटन है N2. समझ पा रहे हो क्या बोला?
Yes, sir.
You have two automatons. One is called N1, the other one is called N2. Am I audible?
Yes, sir, you're audible.
Yes sir.
Okay. These two automatons are accepting the languages L1 and L2, or I can say A1 and A2. जैसे लिखे हो तुम कॉपी में अभी दिखाया था, A1 and A2 are two separate languages. कोई भी दो लैंग्वेज है, उस दो लैंग्वेज का मैंने दो NFA बनाया. Now I have to go for N1 union N2. I have to go for N1 union N2. Then how to find out the N1 union N2? How to find out the N1 union N2? There are two ways. I am saying you both the ways. The first case, listen carefully. Steps also I am saying and designing. Create a new initial state. One thing I am doing something different. I'm giving the names also. This is N1, that's why it is initial state is Q1 and final state is QF. One is Q1, the other one is QF. One indicates initial and F indicates final. One indicates initial and F indicates final. And similarly for this case, one is R1, other one is RF. Okay. These are the two automatons I have designed for two languages. And how to find out the union of these two? Going for the union, what is the rule? Create a new initial state. Are you listening what I am saying? Create a
Yes, sir.
Yes, sir.
new initial state. Create a new initial state. पहले initial दोनों automaton में कौन थे? What are the states which are initial before?
Q1
Q1
and
R1.
R1.
Q1 and R1. Now what you are doing, you have to merge both of them with the operation of union. To go for the merging operation, you have to create a new initial state. Let the name of the initial state is S. Or I can give a name Q0. That is up to you. If you need, you can give any other name. Or QI or initial. Clear? I have created a initial state. The next work is go for the transitions with epsilon. So this and go for a transition to this with the value epsilon. And connect these two with the value epsilon. And here you can see Q1 to QF, there are many states. I don't know how many states, that's why I have not designed it. Getting what I'm saying? I don't know how many states are there, and hence I have not gone for them.
Yes, sir.
And this is the case where we are going for the particular new state and connecting that with the previously existing existing initial state. And here the transitions will be your epsilon. यहाँ पे epsilon symbol नहीं ले रहा है, ठीक है? मैं यहाँ पे लिख देता हूँ, एक काम करता हूँ, क्योंकि यहाँ पे नहीं ले रहा है वो, ठीक है? यहाँ पे एप्सिलॉन का सिंबल देना चाहिए, मगर यहाँ पे नहीं ले रहा है सिंबल, ये पेंट है, इसीलिए मैं यहाँ पे लिख देता हूँ EPSILON. समझ पाए क्या बोला?
Yes, sir.
And this result is the result of automaton This is the result of automaton of what? कौन बोल पाएगा?
Union of M1 and M2.
That is N1 union. अभी समझ पाए मैं क्या बोला? This is one way of doing this. I am moving for another way also. The other way says that I'll go for a initial as well as I'll go for a final. This is the otherwise way I'm saying. I'll go for a initial as well as I'll go for a final. Then I'll join the initials of the previously existing automaton to the initial of this. And I'll join the finals to final of this. Try to understand how to design. And all will be joined with the value of epsilon. All will be joined with the value of epsilon. समझ पाए कैसे किया? And in this case, what will be the final state and initial state? Here the initial state will be this one, and the name of this one I am giving Qi as the new initial state, and I am giving the name of this one is F. This is I. And for these cases, this one will be removed because I have created a new final state. Getting what I'm saying? This is another way of designing the same case with the case of union. Understood? Understood?
Yes, sir.
Yes, sir.
These are the two ways by which we can design union of N1 and N2. This is also N1 union here the transitions are with epsilon. You can give the symbol. Actually, here the symbol is not working. That's why I'm writing a lot. Okay. You can use the symbol of epsilon whenever you are representing in your copies. कॉपी में जब लिख रहे हो तो ऐसे एप्सिलॉन मत लिखो, एप्सिलॉन का सिंबल दे दो. समझ पाए? समझे क्या
Yes,
बोला?
sir. Yes, sir. Yes, sir.
Then these two are the concept of union. These are the concept of union. Any doubt?
No,
Any
sir.
doubt? Similarly, you can go for the concept of concatenation and clean closure. So going for the concept of concatenation, I can say that if there are two automatons, similarly one is N1, other one is N2. These are two automatons. एक है N1, एक है N2. These are two automatons you have. You have to find out concatenation of this. Then how to find out the concatenation of this? Here there is initial, here there is final. and I'm going for making two automatons N1 and N2 like this. Control V, Control V. Control. Then how to go for making its concatenation. For making a concatenation, listen carefully. You have to make the initial state of the first one as initial, and you have to connect the two with the help of an epsilon. Okay, this is the case. The first one is Q1, next one is QF. Previously it was there, now it will be removed. Then I will go for this one. This one is your R1, this one is your RF. Now what to do? You have to go for here. I am writing epsilon in short, EPS. This means epsilon. I don't have space, that's why I'm writing like this. This one is your N1. This one is your, this box is showing you the N2. And this one is known as N1, N2. This is known as N1, N2. तो समझ पाए क्या करना है? मैं बोल रहा हूँ, सुनो. Make the initial of the first automaton as initial and make the final of the second automaton as final. And join both the automatons with the help of an epsilon. And what you are getting, that is called concatenation of both. That is called concatenation of both. Understood?
Yes,
समझ
sir.
पाए?
Yes, sir.
Yes,
Yes.
sir.
This is called concatenation. Another way also is there. I am going for, क्योंकि तुम्हारे बुक में एक ही एक तरीका दिया गया है, मैं तुम्हें दो तरीका बता रहा हूँ. If you go for the book, you will find out only there is one way given in your book. But I am going for some more ways to make you clear about this concept. Here what I am saying, let this is N1, this is N2. इसे अलग अलग बनाओ, पहले N1 को बनाओ, फिर N2 को बनाओ, और फिर इसे कॉम्बाइंड डायग्राम बनाओ. तो N1 क्या है? ये था तुम्हारा N1, हाँ कि नहीं? अरे तुम्हारा N1 ऐसा था. तुम्हारा N2 कैसे था ना, ऐसा था. दिखाई दे रहा है? दिखा रहा हूँ, ये था N2. तो इसे मैं और एक तरीके से बना सकता हूँ, कॉम्बिनेशन ऑफ बोथ. One is N1, other one is N2. And here what I am saying, here N2 is having a final state like this. And here the final state name is RF. RF. So the same condition holds. Here I am using the concept of epsilon. Here I am not using the concept of epsilon. The only difference is that much. Here what I am saying, that I'll remove this final state from the middle, and the initial state of the second automaton the initial state of the second automaton is combined with the final state of the first automaton. Repeating again, the final state of the first automaton is combined with the initial state of the second automaton. That means here the state name I am showing you, it is QFR1. ये वाला कॉन्सेप्ट समझ में आया?
यस सर।
Yes, sir.
ये जो इनिशियल ये जो फाइनल दोनों स्टेट को मैंने एक ही स्टेट बना दिया। यहाँ से आके जहाँ पे खत्म हो रहा है द सेकेंड वन का शुरुआत वहीं से होगा। Then these
Yes,
two
sir.
are representation of concatenation operation.
Concatenation.
Okay. Any doubt? Anyone is having any doubt?
No, sir.
Then this is the way by which you can go for designing the finite automata. And one more operation I'm going for, that is called clean closure, or I can say the star operation. How to go for the star operation? For the star operation, you have a finite automaton like this. Let this finite automaton I am taking, this is having multiple number of final states. These are some of the final states. I'm going for only two final states because it's possible that the automaton is having two final states. Yes or no? The automaton may have two final states. That is, the possibility is there. For that possibility, I am considering that this automaton is having multiple number of final states. But it is not true always. There may or may not be. Cases are like this. Here I am going for an initial state also. Then this is the automaton that is available with you. Then how to go for the clean closure of this? Also, I am going for two ways to represent it. One way is given in your book. The other way I am saying how to go for this. The ways represent that. Clean closure का मतलब क्या है? कौन बोल सकता है? तुम में से by self. Repetition of a element. Yes or no? Here it is saying, your book is saying, create a new initial state. पहले ये था तुम्हारा N1. इसमें क्या था? ये था initial state Q0 और Q1. Final start था F1 and 2. ये final state था. और यहाँ मैं जा रहा हूँ, ये था तुम्हारा R1 और ये फाइनल स्टेट था F21 and F नहीं चाहिए, मैं हटा देता हूँ। ऐसा एक ऑटोमेटन था। According to your book, the star operation is known as create a new initial state. This is a new initial state created. Let the state is created now. Then its name is I or initial or QI. I am writing initial state. Then what it is saying, make the state as final. It is saying that make the state as final. That means now it is the final state. And join this with all other states with the value of, here I have joined, with epsilon. That means यहाँ पे पूरा ये हो गया है, N1 यहाँ पे आ गया है, मैं इसे ऊपर ले जाता हूँ. Then the transitions are here with the value. सुन रहे हो तुम लोग?
यस सर।
क्या करोगे इसमें? जो कनेक्टिविटी होगा होगा, मुझे वो पता नहीं, मगर मैं क्या बोल रहा हूँ, यहाँ पे ऐसा कनेक्टिविटी तुम्हें देना है, अगर नहीं है तो ये जितने भी लगे हुए हैं सारे के सारे का ट्रांजिशन क्या रहेगा? एप्सिलॉन. इसीलिए मैं एप्सिलॉन नहीं लिख रहा हूँ, यहाँ पे ईपीएस लिख रहा हूँ, मतलब एप्सिलॉन ही है. कनेक्ट दिस with the value epsilon. यहाँ से यहाँ फाइनल से इनिशियल, फाइनल से इनिशियल किस में रहेगा? एप्सिलॉन से रहेगा. फाइनल से इनिशियल कैसे रहेगा? एप्सिलॉन से कनेक्ट करना है तुम लोगों को, और ये न्यू इनिशियल से इसे भी एप्सिलॉन. This is the way that is given in your book, but I am showing you an easiest way. तो easiest way क्या बोल रहा हूँ? Create a initial here, create a final here. This is another way of clean star operation I am showing you. क्या मैं एक ही तरीका है, मैं तुम्हें दो तरीका बता रहा हूँ, जो भी तरीका यूज करोगे दोनों के दोनों सही है, कोई भी गलत नहीं है, इतना मालूम है. और ये सेकंड वाला तरीका जो मैं बताया हूँ वो मुझे लग रहा है ज्यादा इजी होगा तुम लोगों के लिए. तो क्या करोगे? Connect the initial newly created with the existing initial with a value of epsilon. Connect these finals with the value epsilon. Also, go for this one. The value epsilon. हो गया. And this is called lean closer. Now, with this, we are finishing our discussion with the concepts that how two automatons are combined with the operations union, concatenation, and clean closure. Here, all the transitions are epsilon transitions. All the transitions are epsilon transitions. Got it? Here,
Yes,
this
sir.
is called, this is Qi, and this is called Qi.
QA.
This is called lean closer. This is N1 star. These two are for N1 star. Have you designed in your copy? Copy में डिजाइन हो गया? मैं बंद करूं इसे?
Yes, sir.
Yes, sir.
By using these techniques, you can combine one or two automatons with the regular operations. Clear? And
Yes.
one thing I have missed here, that is for this final diagram, these final states will not be final. These will be non-final states. The final state तुमने पहले ही बना दिया है. Correct. Is that the no? Clear? Any doubt?
Yes, sir.
Any doubt? किसी का कुछ डाउट है? किसी का कुछ डाउट है? जो पूछ रहा हूँ बोलो.
No, sir.
No, sir.
Then for quiz, I'm sending you a quiz. Within 10 minutes, I will must receive the answers. समझ रहे हो क्या बोल रहा हूँ? हेलो?
Yes. Yes, sir.
मैं तुम्हें क्विज का क्वेश्चन भेज रहा हूँ. उसका आंसर मुझे 10 मिनट में चाहिए. और मुझे सिर्फ इतना कंफर्म करो कि वो जो क्विज बोल रहा हूँ उसका तुम्हारे पास पहुंचा कि नहीं. कंट्रोल V सेंड. हो गया तुम लोगों का. देखो.
सर हम लोग अभी क्लास लीव कर सकते हैं क्या?
हाँ, क्लास छोड़ सकते हो. बच्चे पहले बोलो लिंक मिला है कि नहीं.
हाँ सर मिल गया लिंक.
और सर 9 से 10 वाला भी क्लास छोड़ दे, क्विज पहले करे.
क्विज कितना टाइम लगेगा? 2-3 मिनट लगेगा.
ठीक है.
तुम्हारा 9 से 10 के बाद कब क्लास है?
10 से 11.
फिर कंटिन्यू है?
सर फिर 11 से 12 ब्रेक है सर हम लोग का.
तो काम करो, मैं 11:30 तक ओपन रखता हूँ. उस टाइम के अंदर दे देना. ठीक है?
ठीक है सर. ठीक है सर.
By
ठीक है.
11:30 you respond.
ओके सर. थैंक यू सर.
Okay, thank you. Okay.